Welcome back to another CommCon Virtual 2020 session, this time with Lorenzo and Alex from the SIP Capture and HOMER projects. Both of them have been dear friends to me over the past 6-7 years, getting to know them, getting to know the projects. The HOMER project is kind of a really cool thing for me. I'm a web dev at heart, and so kind of coming into this space and going, oh, what the hell is going on? HOMER was like this fantastic thing that enabled me to kind of just see everything that was happening. And then seeing the evolution of HOMER over the past however many years, from this kind of monolithic thing to HOMER just being this web app with all of these other projects around it, has been really, really great. And just enables so many companies to kind of progress with their internal ecosystems. So hello, both of you. How has the pandemic been treating you with open source, with business? We've all been kind of having these different experiences across the world. So I'm quite interested to see how that's impacted you.
Well, it actually ended up impacting us positively, because if it's true that on one side, we had a little bit of a slowdown, with all of our usual networking, conferences, meeting, and the development cycle, our market has increased. So almost all of the parties that we work with have raised their call volumes. Faced new challenges. So it actually gave us a huge opportunity to, grow the product. This is what we always do. We try to match what real life scenarios pose as problems. And we actually managed to double our team in the process. So, a lot of people, lost maybe their job. And I guess we gave some of them a new one. So we actually scaled our team up during the pandemic. We had some time to sit down and think about the actual code and the actual project. So we took that chance to invest in and improve it, and hopefully we walk out of it bigger and better than ever.
That's fantastic. It's nice to hear a positive story from the pandemic that has affected all of us, and the reason why we're not in an English countryside mansion right now riding segways. Great. Well, I'm just going to pass it over to you two and hear more about what the HOMER team, SIP Capture, QXIP have been doing. And I'll catch in with you all after this session. Cheers.
Thank you, Dan. All right. So unsurprisingly, today we're going to be talking, of course, about HOMER. First of all, a little bit of an introduction. Our company is QXIP or QuickSIP. We're a research and development company focusing on open source packet capture and RTC monitoring technologies. We started, Alexandr and I, around 2007. And we formed it to independently support HOMER as a project and the HEP ecosystem. It's been a lot of years, and we've followed and assist thousands of deployments from the smallest company to some of the largest telecoms and enterprises out there. And luckily enough, we had a chance to see what their real life issues and what their mission critical scenarios were. And on top of that, we have built the next generation of HOMER. And today we're going to be talking about some of the improvements that we managed to include in our current release and what they do. And together with Alexandr, we're going to try to give everybody an insight or engage them, make them curious to try it. So just a quick recap before we get into detail. HOMER is really a smart perpetual capture stack covering many protocols. It's the focus on VoIP and RTC, and it's basically its job is to capture everything and streamline the complexity of our environments into something that's easy to search, easy to visualize, easy to make sense of, and in the same context also produce time series that tell us what the elements that we're monitoring are doing at a specific point in time. It's a packet troubleshooting time machine. It's built on top of the HEP encapsulation protocol, which Alexandr has created many years ago, and it's really the foundation of everything we're doing because it features native integration in many platforms that we all depend on. On the other side, we try to do the same, so many open inputs, many open outputs, the new HOMER supports industry standard backend. So we write to Postgres, Prometheus, InfluxDB, we interact with Grafana, we send logs to Loki, all modern platforms that people are relying on and using. So we, have our attention on integration more than ever, so that people can, mix our platform with other platforms, and we become part of an ecosystem. So whether it's a classic IP telephony setup, modern VoIP stack, or bleeding edge WebRTC, HOMER is designed to be ready to produce value. So if we look at the lifetime of our HAP packets, something, of course, always spins off a packet, be it SIP, RTP, RTCP, maybe a log, maybe a CDR. This will get captured by what we call HAP agents. Those are capture agents that have exactly the role of getting the original data, encapsulating it inside of a HAP packet, which is like an onion, and sending it forward for storage. Once those packets land into the core of HOMER, which is today Amplify Server and HOMER app, they get indexed, they get tagged, they get divided depending on their type to parallel backends where they're ready to be found and used for troubleshooting. And it's all designed to make an engineering team's life easier. This is our background. We were voice engineers. We had to solve this problem for ourselves. So HOMER has been evolving, and many people already know it. But this year, really, we managed to release some very, very sensible improvements into the platform in terms of features. So looking at some of them, many are on the front end, because this is where people consume the data. So it's nice, and we have a lot of magic in the background in terms of capturing, reassembling, and doing a lot of things with packets. But in the end, people interact with them when they're stored. So we added dynamic search forms to the platform with auto-completion that make using it a snap. We improved the way we display flows, statistics. We added protocol filtering, all things that we're going to see. Very important, we added these mapping and transform functions, which can modify the data as they, or packets as they come in and out of the platform. We made HOMER able to query external databases and API. We created a version of the view that can be integrated in customer portals. We have added on the client side support for WebSockets. So now browsers can send data directly into HOMER, which is quite revolutionary in terms of what we can do. We have added Lua-JIT pipelines to our agents so that they can also modify data to either anonymize it, adapt it, do lookups, a bunch of things. And all of our agents are now static and portable for any modern OS, also ARM64. We keep expanding on the time series support. Right now, we natively can write to Prometheus, InfluxDB, and Timescale with custom tags, extractions, a lot of things that can be done. And then, of course, we expand on our integration front. So today, a bunch of platforms, and here, you can see some egregious names from OpenSIPs, Kamailio, Asterisk Friedrich, all the way down to the modern platforms and RTC gateways, Janus, MediaSoup, Jitsi, RTP proxies, RTP engine, as well as external platforms such as CG Rates or competing products such as VoIP Monitor. They can all be latched together now with HOMER. We also have a bunch of commercial extensions that we made available to our customers for specific use cases. So let's start by looking at some of the UI features. You can already see here a screenshot of the modern release, which is way more colorful and easier to navigate. But it all starts with search. So this is a search application. We have a bunch of widgets that we can configure and add to dashboards. Just like people come to expect from modern environments. Everybody can have their own widget. But again, search is where it all starts. So I'm going to start from there. HOMER features support for many protocols, as probably most people know. The classic one is SIP, but we can actually index just about any type of data that we can give a schema to. So, for instance, Janus events or generic logs and CDRs or RTCP statistics, they all have a type within the HAP ecosystem, and they can be indexed. Once they're indexed, they can be searched, but it was always a little bit complex. Today, we have custom search forms per protocol. So you just select the protocol that you want to work with, and HOMER automatically provisions a set of fields that can be assembled with a drag and drop concept. So it's really easy to build your custom form to perform the activities that everybody needs to do on a daily basis as fast as possible. So you just choose a protocol. In this case, we're looking at a SIP call. it matches the config that Alexandr will get into later, and there it is. If it's not fancy enough, because this is still a multi-field protocol that we end up getting, we also have a new one that's called a smart search form. And this is inspired by Grafana Explore or Splunk or Loki and other platforms that offer basically a one form dynamic way of composing search filters. In this case, it comes with an autocomplete functionality. So you just select the fields that you care about, you make and or queries up to your likes, and off you go. This also allows us to create much more compact dashboards, because results now can be displayed just next to the form. This was like a weakness, I think, of our previous design, where people continuously had to switch back and forth between search forms and results, making them slower, making it complex. Right now, they can coexist just next to each other, and they just can save an incredible amount of time. We measured like 30-40% of performance increase when working with this method compared to the classic one. So now you know that you can use different types of forms for different protocols. Once you search, we get to the results page. By the way, everything is based on time ranges. So the first thing that you would normally do is select the span of time that you're interested into. In this case, calls during today. Put some parameters or none if you just want to look at everything, and click search. At this point, you should be presented with something like you're seeing now in the slide. The results can maybe at first be intimidating unless you're dealing with a protocol that you know well. And we designed this part as well to be as user-friendly as possible. So users can hide, rearrange, and choose the type of columns that they want to see when they search HOMER. And this is applied to each individual user. So Alexandr and I can have a different interest in terms of what we want to see when we search, and this makes it completely possible. So, it's also drag and drop based. So all you have to do is just look at the available fields. In this case, we're looking at SIP protocols. So we have things like call ID, payload type protocol family, and all of the SIP headers, request URI, from, to, tags, and etc. They're all available. You can just drag them into position and create your own form. And that's as easy as it is today to create your own environment. Once we get into our results, of course, we can select them. And this is where the magic happens. So when something is selected in HOMER, a bunch of backend activities take place, mostly to find all of the matching elements. So we're going to select a single call ID, for instance, and from this call ID, we can find a B, a C lag, any logs that are related to that traffic, and display them all together. So it's basically doing all of the hard work for you and presenting you the results at once. In the results, we have multiple views, messages, where you can see all of the SIP messages, of course, their timing, from, to, etc. But you can also see here logs, RTCP messages, and anything else. So this container now became much more powerful. The same you can do in the flow, where we can look at the traffic between hosts displayed as columns. And in this case, we have added a bunch of additional functionality that I'm going to show you to filter this. Same time, you can see the media quality statistics with charts, and you can select between all of the hosts that we have detected. So for complex calls with multiple endpoints or RTP proxies, we can individually look at their performance. And then, of course, display logs and export everything as you came to expect from HOMER in multiple formats. So once we're displaying, we mentioned all of these results, we can end up with complex sets of messages and multiple sessions. One of the new features that we think is really going to change the life of our users is filtering. So now users can quickly choose what protocols are being displayed on screen and or select which session. So in the case of automatic correlation, you might end up with multiple sessions, and it's sometimes confusing to tell them apart. Now it's as easy as clicking a couple of buttons. Behind all of this, as said, is mapping. So mapping is the part that allows HOMER to start from a single packet, find its sessions, and everything else. And Alexandr is going to take us a little bit inside of the engine, under the hood, to tell us how this is working.
Thank you, Lorenzo. So it's just before we dive deep to this mapping, it's to better to understand if what data what we store in HOMER right now in database it's normally it's schema-less, yeah, and it's based on JSON methods. And in this case, we store data what we receive from SIP protocol or we receive from IP protocols, and it was serialized and stored in database. Lorenzo mentioned already proto search widget, and what you can select any fields to make possible to search on any information inside of the zip message. And to make it use it easy, you have to describe this concept in mapping fields. This in these mappings, it's a JSON object which says which fields you would like to use for search, and which type of this field is it, and some default values what you can select, etc., etc., etc. For example, just a couple of days ago, one of our users opened a ticket in HOMER repository and said, it's everything, it works fine from box, but I would like to make search by from domain. And from domain, this was not by default mapping schema. And we immediately replied, yeah, just go to these mappings, just add a field which you expect, and it will be automatically displayed in proto search widget or in smart search widget. It has been done in probably in 10 minutes. And the user was happy, said, it's awesome, so I can extend, can make any manipulation with data inside, it's great. In HOMER 5, if you remember, it was based only on C protocol, like a start point. In HOMER 7 and 7.7, we tried to go away from this concept, and now you're able to make search or any type of signaling or what you want. For example, you can implement it CDRs inside, you can implement it WebRTC, and you can immediately make a search. But how you would like to correlate data with some additional stuff? Or, for example, you have a SIP, you have the B2B engine, and you have WebRTC data, you have logs, and how you will correlate it. We have created in this case, we have created correlation mappings where you can describe a scenario, how you would like to correlate data and how you will get data from this table to make search in different table using some fields, and etc., etc. If you, Lorenzo, can you go to next slide? Thank you. So here it's a small schema how this correlation works. For example, we have SIP, we have call ID of SIP, and we can create a correlation mapping which will get data based on same call ID from RTC stats or log CDRs, and we can display. But what if we can and how we can make some correlation with call ID which is not similar what we have in our main scenario. For example, we have some suffix or prefix. Here in this case, we have suffix 99. We can add this suffix and may look up in database. We can describe what we can also to get all information from RTCP tables. We can get CDRs tables, and we can even make some deep correlations using external data. So if you go to next slide, you see what we have implemented, because we hear our users and all requests. We implemented here scripts which you can execute in correlation scenario. In this case, you can create a script. It's called, in this case, test function, and you can assign these scripts to input procedure, where in this script it will be executed on backend, and in this script you can do any manipulation with call ID or correlations ID. You can add additional suffix prefixes. You can extract some middle part of this call ID and give this correlation ID back. And database will use this correlation ID to fetch data from database and display in user. It's just for example, here it's on screen. You see exactly simple script which does exactly this. It's add suffix and to the end. And in this case, it's B2B call, which very famous in zip-wise scenarios. And you will fetch all data, and you will display two call ID and same transactions. But it's not what we implemented. We also implemented output script, which is more powerful feature. If you, for example, you will get all data, but you would like to make normalizing or be to change some data what should not be displayed to end user. And in this case, you can implement an output script. And in output script, you can do any manipulation with existing data what you have stored in database. And you can change IP, you can make topology hiding, you can make some extraction. And if you go to next page, Lorenzo. Yeah, thank you. So here it's two examples how easy you can do any manipulation with the existing data. For example, in first script, you can change DB node. For example, if you have multiple nodes, you would like to make low distribution, and in this case, if it's DB node equals something, you can change it, and database and UI will send request to another node. Or if you would like to make some topology hiding, and you don't want to show your original IP to destination original IP to end user, you can also do some manipulation, and you can change and set this Google the NAS IP here and store it to database, and it will be sent to database. Also, from next script, you can do some additional correlation injections and et cetera, et cetera. So it's very powerful. It's even too much powerful because you can do any manipulations, you can do any sets, et cetera, et cetera. On next slide, you'll see exactly the result, what UI will receive in API call. You see what we injected super correlation data. We changed DB node to my node. We set destination IP. We changed from user to anonymous, and it's also compliant to GDPR, so you can make any data hiding. And it's even will be great for some troubleshooting if you would like to provide data what you store in database to your end user. It's everything what I explained here. It's we do with data what already stored in database. But what if we would like to make some manipulation before data will be stored to database? It's very important to mention what in Haplify server we implemented two engines. It's Luogit and Go Expression, which give you a freedom to do any manipulation. You can add some tags. You can execute some custom logic. You can do some extra extraction from any messages what Haplify server will receive. And in this channel, you see it's Hap, it's Luogit executed script. Script does some changes in pipeline and give this object back to Haplify server, and Haplify server store it to database. On next slide, on 26, it's a Luogit example how you can do some custom extraction from zip messages. For example, Haplify server doesn't do all extraction, all fields which exist, and probably in your scenario you have some additional header which you would like to take from zip messages and store to database. In Lua script, you can do it easily. You can extract this message. You can set this custom header in object, and it will be automatically stored to database. So now you have absolutely freedom to do anything and store everything in database. Also, for example, if you would like to add some additional tags to zip message or to zip transactions, you can also it's also possible here. For example, you would like to make tag if user agent is zip features, and you automatically can add additional tag to this record. And later in user interface, you can do search by this tag and see if any grouping exists, and you can do easily search. Or, for example, if you would like to see how many packets are coming from this group, you can do also grouping by IP, and this IP will be related to some tag, and you can store it to database. So now you can use both engine, Lua-JIT, and expression, Go expression. Of course, Go expression, it's a little bit faster because it's native implementation in Go, but Lua-JIT has a little bit bigger background and also good documentation. And in this case, you will make choice by self, which scripting language you prefer, or easy to understand, or it's better performance. So it's absolutely depends on you. And now you have any possibility to do the data manipulation in pre-mediation and post-mediation.
Thank you, Alexandr.
So, yeah, Lorenzo, I give you back microphone so you can continue.
All right, so very quickly going into the rest of the stack. So now we understood that basically the HOMER components act like we came to see from other proxies and so on. So data can be actually modified, not just stored. But as we said, as we process all of those packets, all of those messages, we also keep tabs of the statistics. So where are they? HOMER writes and reads, as we said, to multiple data platforms. In this case, InfluxDB, Prometheus, or TimescaleDB can be used as targets for statistics. In this presentation, we're not going to get into full detail on those because it would take hours on its own. But basically, you have all a full set of standard KPIs or custom KPIs. You can attach tags that Alexandr just explained to those KPIs. So through the scripting, either in the agent or post, you can decide that something belongs to a specific group based on IP or features of the signaling. You can send everything to standard platforms, and at this point, most of our customers used to love Grafana for centralizing their view, and this is what we did with HOMER. So now instead of forcing them to come in HOMER to see the data, it's the opposite. We send it to a standard platform, and HOMER and other platforms can both feed. In this case, Grafana is the centerfold, and most people use that. So we actually ship a bunch of presets for Grafana that have been prepared by NAGB originally and then expanded by our customers that give you, all of the KPIs and metrics that you might be interested in starting from to monitor a VoIP or RTC infrastructure from, let's say a SIP protocol perspective, but also in terms of media quality, averages, and so on and so forth. Those are published on Grafana.com, so they can be imported into any Grafana and just attached to our statistics. If you're interested into this, we did previous presentations that go into full detail. What else is there? Well, WebRTC, the elephant in the room. So HOMER has been RTC generically ready for a long time, but it's a little bit of a well-kept secret, and not many have explored it in full yet. So we're looking for use cases. As said, the latest version of HOMER supports HEP over WebSockets. So it allows to create app clients directly into the browser. So we can send native RTC statistics, custom signaling protocols, even the console log to HOMER. So we can use it to do remote troubleshooting of public endpoints, really, with or without a proxy. This is for the client side, and in a similar way, we monitor the Jitsi statistics in the stack. We also do support server side, of course. So if you're using Janus or MediaSoup as your SFU, they both already are supported. So we have a HEP-up, which is our little converter that turns them into regular HEP. And it can be used to either log all of the events and to turn all of those events that have something to do with media into, again, time series. So that instead of going through thousands of events, you can just look at a chart in Grafana that tells you, how many packets were exchanged, what's the average quality of a call, all tagged by the internals of those platforms. So session IDs, opaque IDs, and anything else that they offer is natively reflected inside of HOMER. And this is for the data that we can collect internally. But what if HOMER doesn't have all the data itself needed to piece a picture together? What if the customer already has some of this data elsewhere? Let's think of CDR, logs, call recordings, something that's already being handled by another system. For this, we have created HEPSUP. HEPSUP is simply a PubSub API attached to search and correlation parts of HOMER. So every time somebody selects something, it gets triggered. agents can subscribe to FSub and provide additional capabilities on demand. For instance, I can create a little gateway that looks up CDRs in a database based on the call ID and a time range and returns them as JSON objects to HOMER. HOMER will do this interactively and asynchronously. So when somebody selects a result, if there's any FSub agent subscribed, there will be sent query, they can return data, and it all gets merged into the same view. So this is basically a super tool that allows you to connect HOMER with any other data set without any programming. So this is done completely out of the core as an external element. And we already have examples that connect HOMER to CG rates, to VoIP monitor, so even a competing product, or to Elasticsearch to get logs. This is all open, of course, so it's very easy to take any of those and adapt it to another backend or another purpose. And we hope to see a lot of contributions there. So looking again at the big picture one last time, on the left side, the agents, the entry point. So we have a really, really broad range of integrations. We have our own passive agents. We have log sniffers. We support browsers. We have native agents in a bunch of key platforms in our ecosystems. We support the leading WebRTC platforms. It's really all you can eat here. And if it's missing, we have the tools to create it. All of those can generate HEP to some extent, send it to our core platform where packets can be modified before and after ingestion, where data can be split to searchable indices, time series, and be really programmable. So this is a programmable monitoring platform by now, including the external lookups with FSub. And the core point, of course, is to make everybody's life easier as they troubleshoot complex issues, and of course to give people a chance to improve, not only on their product but on their own experience, learn more about the protocols and the ecosystems that they work with. So hopefully, we covered just about anything that's out there. If you're ready to install it, as we hope, all you have to do is choose the method. We have a quick install script that can be run on a vanilla server running Debian 9.10 or CentOS 7.8 and derivatives, so also Ubuntu and everything else. It's all made with packages, or it's the past times of having to compile, download, and clone are gone. It's just a couple packages maintained through our own private repositories that everybody can use. So running these 3 lines gets you a HOMER that you can upgrade every day if you wish, transparently. If you prefer to containerize, we have daily builds of all of the elements inside of Docker containers. Dan is helping us also make it a reality on Kubernetes. So soon enough, we'll publish some recipes for that too. And on the HOMER 7 Docker repository, we have examples for just about any combination. So HOMER with or without stats, with InfluxDB, with Prometheus, with timescale, with the UI, without the UI. All of the combinations that are possible are illustrated there. And it's really easy to just bootstrap the entire thing and just use it or see how it fits. We offer, of course, community support. That's the best part of our project, are the people that are involved with it. And a bunch of generous geniuses that are sticking around our mailing list, our repositories, willing to help you. The mailing list is a good place to discuss ideas and concepts. For issues and difficulties, we have GitHub and our repositories. We have a new Discord server where we're inviting people to join for talking in real time. And we also offer, of course, professional support to anybody that decides to use HOMER in a mission critical environment. We offer design, customization, engineering services around the clock, so we can be contacted at QXIP. A last note before walking out of the presentation: please support open source before you ask something out of open source. There's many ways to do so. You can donate, you can sponsor on GitHub, but the best one is to give respect to get respect, which is something that we don't find always happens. But this is really where it all comes from. So if we can form a community, HOMER and other projects that we rely on will go on and on and on. We'll pass them on to our kids, and we're going to be proud of being part of them. Many people don't get it, so it's also about educating and sharing what's really important to make those projects stay alive and pass the test of time. And that's pretty much all we had for our presentation. We hope you enjoyed it. We hope you learn about what's cool in HOMER and how to reach us to discuss it and make it better. Yes, we can. So Alexandr is going to give us a quick flash demo of the HOMER that we just finished discussing. and so you can get an impression of how this looks in real life. Alex, up to you.
So, guys, here it's a presentation about this small demo about HOMER, what we did, how powerful, how nice is it, and how many exactly possibility you have right now to do a lot of amazing things inside of HOMER. If you remember, HOMER was before was static. You have some widgets, and you can do only search, and which will be results on your default dashboard. Now we have widgets result, which is awesome feature what we have implemented in HOMER 7.7. And now, as Lorenzo already said, you can save even 30% of your time doing research. For example, you have this widgets, which is normally proto search widget. You can do any customization. You can select any protocols inside what you would like to search. By default, you can see we selected a zip call. You can add or remove any fields which you add inside of your correlation mapping or inside fields mapping, and you can save it. You can do, let's say, just remove couple of this, and you have a result container where you can say, I would like to see results inside of this container. I'll just make a search, press search, and it will be displayed here. If you would like to, I selected, and boom, here you are. I would like to display data. For example, I'm looking for call, what I did to Lorenzo right now. And I would like to display in default mode, in alt HOMER style. And it will be displayed here. You can click and see all information about this call. Okay, this is not all what I did. Here you are. So this is exactly what I did to call Lorenzo. Yeah? So it's all information. This all messages is described in flow. You can also possibility to show TP, SIP. You can make a group by alias, by ports. It's a lot of information. Also, nice feature what I can show you here. If you click on message and you have, for example, zip I or zip T. And here we have decoded tab, which will be automatically using T-Shark, decoded all messages, and you will receive JSON object from T-Shark already parsed. And all information, for example, if you have ISAP SDP, and it will be extracted and it will be displayed here. You see, it's output from T-Shark. In this case, if you have some additional protocol, for example, if you have H248, yeah, and or any data what can be dissected by Wireshark, this feature, it's already give you possibility to do any display any data what you want. So also we have some QS. It's we did a lot of exactly job here, and now we display MOS. We have packet loss. We have some information for each direction. For example, here it's called to Lorenzo, it's this called to me, and we can display data exactly selected by this stream, and we would like to see any packet loss here. Let's see. You see, it's no packet loss, but we would like to display most data, and here you are. Boom. We have logs. We can do search in Loki, as usual. This is information what's stored in Loki. We can extract some data what we need. We can make tags. We can make some search. This data has been inserted by Haplify server. And we have also export. We can export with PCAP. We can export with share link, what you can send to your customer. Also, what is very important, we have HOMER view. HOMER view, it's, for example, if you would like to give some share link to users which should not have access to your HOMER database. So this is HOMER view, which will be display same information what you have on right now on screen, but without authentication. So the authentication will be internal. So this means what you can integrate it with HOMER view to your CRM system, where user can log in and see information or all call details what he did. This is very nice features. Here, what I already explained, you have possibility to make extended or short format. You see some if you have a big or huge call scenario, which will give you possibility to make a short version. And you have also possibility to display only RTP information or RTCP information, or if you have some WebRTC stuff or log stuff, it will be inserted here as well, and it will be displayed. What else? We have also what is very nice feature. We have integration in Grafana, and you can inject and any dashboard or any widgets from Grafana what you have already, because many of you already have Grafana or Prometheus or InfluxDB installed on your system, which collect all monitoring information, and now you can inject this panel easily to widget. You see some information here. Okay, this was just an example, and if you would like to see more details and click around, go and check install the HOMER, and it will be amazing. You will be shocked how big and good is it.
Thank you both. That was great. I'm always amazed by everything that HOMER can actually do, everything that it can kind of interact with and interop with. The fact that you can push data in from your app that's dealing with all of the logic, so that you can see logic logs plus SIP logs and get this whole great big picture and go, that's where the issue was, and the issue is in my application code based on this log. I think that's really, really powerful, and you guys are able to show everything together. It's fantastic. Something that I forgot to mention earlier was the QXIP, our community sponsors for CommCon, and they are an absolutely fantastic team of people who truly care about the community and want to make it better for everyone. So thank you very much for sponsoring CommCon. They're going to be available in Riot as sponsors whenever they're around to answer questions around QXIP and how they can help you with HOMER and all of their other projects. And then we're all going to head off over to riot.commcon.xyz. The link will be in the description below, where we'll be able to do live Q&A with Alex and Lorenzo. So for a final time, thank you very much, both of you. Don't go anywhere quite yet, though. We've got to say thank you to all of our sponsors. Without them, none of this would have even happened in the first place. So for our platinum sponsors, we've got Toulouse, Voxbone, and Ciara. For our gold sponsors, we've got the Matrix Foundation, Vonage, Sangoma, Telviva, and Loway. Our silver sponsors are Aptosay, Pion, Telco Bridges with ProSVC, Avoxy, 8x8 with Jitsi, and FirstCom Europe. Then we've also got community sponsors, QXIP and Cycol Systems. Without any of them, this would never have even happened. You wouldn't have had all of this free content on YouTube. So go say thank you to all of them. Go look at what they provide, what services they offer, and have a conversation with them all over on Riot, riot.commcon.xyz. The link will be in the description below, along with links to all of our sponsors. You can go and watch preview videos from all of our gold sponsors right now over on YouTube. The links will be somewhere over here. All I've got to say is thank you to all of our sponsors, and I'll see you over on the Q&A shortly. Cheers.